Hello, welcome to this channel Sharda e-learning. Let us consider the numerical examples of first chapter, Gravitation. These examples are important for the point of view of our board examination. There are 7 examples in the exercise. First example, say question number 5a. An object takes 5 seconds to reach the ground from height. What is the meaning? Object take 5 seconds to reach the ground from height 5 meter. Height is 5 meter, which is also called as S, 5 meter, and its time is 5 seconds. What is the value of G? This is the kinematic equation. There are 3 equations of motions. Out of that, this is S is equal to ut plus half gt square, as well as v square is equal to u square plus twice gs, and v is equal to u plus gt. This is the one formula which we can use. S as a 5, u, here is a object takes 5 seconds to reach ground. Initial velocity is 0 here, therefore 0 into t, initial velocity is 0, plus half g we want to find, and t square, that is 5 square. Here 5 is equal to 0 into t, 0, half into g into 25. Here 5 into 2, 10, g into 25, and when we take g on one side, then we can write 10 upon 25. What is this? 0.4. And the unit of G is meter per second square. This is the very simple example by putting the values. H as a 5, T as a 5, U is initial velocity, which is we call it as a 0. Then by our usual calculation, we can find the solution and the answer with the unit meter per second square. It is G is equal to 0.4 meter per second square. Okay. Next, that is 5b. Say the radius of planet A is half the radius of planet B. What is the meaning? One planet is A, second planet is B, and the radius are given with the comparison. Radius of A is half the radius of planet B. Suppose for planet A, we say for planet A, say mass is say ma. This is our symbol. Radius is say capital R A. Then the radius is half the radius of B. Therefore, from this we say that RA is half the radius of planet B, and we use this expression in this example. If the mass of A is ma, means we write mass of ma, which what must be the mass of B, means what is mb. So that we want to find mb. What is the, so that the value of G on B is half that of value on A. Again, we have given value of the G at B, means planet B, is half the value of the G on A. This is also which is we are given, and we know that this formula, small g gravitational acceleration, capital G universal gravitational constant, which is always we use as a 6.67 into 10 raised to minus 11 Newton meter square kg raised to minus 2. M is mass of that planet, of that earth, of moon, whatever it may be. Here we consider mass of planet A, mass of planet B. Hence this we can write as like the GA is equal to G MA upon RA square. GB is equal to, we can write G MB upon RB square. For planet A, for planet B, we can write as like this. What we are given again? This is given. GB is equal to half GA, means GB, this is the GB, is equal to half GA. What is GA? GMA upon RA square. Means here with the help of this expression we can write GB, that is this RHS GMB upon RB square is equal to half this expression. GG cancel. Now we want to express this in relation with mass of B and mass of A. Therefore take MB on this side, RA square on this side. Then RA square is 2 upon RB square is equal to MB on this denominator and MA as it is. We can write as like this. Now we reuse this expression. RA is nothing but half RB. RA is nothing but half RB. Therefore RA square means half RB square. RB square as it is. Now our usual calculation. Here 2 and here is a 4, isn't it? Therefore 2 square, that is 4. 2 into 1 by 4 into RB square upon RB square is equal to MA upon MB. Here cancel and RB square also cancel. Therefore half is equal to MA upon MB. Means MB is nothing but by cross multiplication 2 times MA. And what we want? What must be the mass of B so that the value of G on EB is half that type of its value on it. What is that mass? Twice the mass of planet A. Mass of planet B is the twice mass of planet A. This is the answer of this question. Here only we consider this formula, and for planet A we use symbols. For planet B we use symbol RB and MB, and we have given radius is half, we have given G is half. Therefore we use these two at this place. We write this expression and we use here this expression. Then by our computations we get this solution. Next question, that is the mass and weight of object on earth are 5 kg and 49 kg. What is here? The mass and weight. Mass, we know that mass cannot change. Whatever it may be, mass cannot change by changing the place or by changing the location. Therefore mass is equal to 5 kg. It is the same and everywhere on the earth. Mass and weight of the earth is G, weight, that is, suppose we write this expression as like this. W, what we want to do, what will be their values on the moon, say. Therefore we write WM, MM, gm. Means weight on moon, mass on moon, g on moon. G means gravitational acceleration. We know that g is 9.8 meter per second square on the earth. But here what we are given, 49 Newton is weight on earth. Means W on earth is 49 Newton. Therefore W on moon, what will be W on moon? Here what we can do for this expression, m cannot change because mass cannot change, therefore we write 5 as it is. Okay, then here we assume that, here we are given, assume that acceleration due to gravity means g. G is, what will g on the moon is, g on moon is 1/6 g on earth. Means we can write g on earth is what? G on earth is 9.8. 9.8 upon 6. That is, you may say 1.63. 1.63 meter per second square. We use here gm as 1.63. And then by calculation, 5 3 15, 5 30, 31, 5 what will happen? 5 3 15, 1 5 30, 31, 5 8. 8.15. This will be weight on, this is the Newton, weight on moon, because weight is force and unit of force is Newton. Therefore weight on moon will be 8.15 Newton on the moon. Therefore what will be the value on the moon? Weight on moon is 8.15 and mass on moon is, mass on moon cannot change, 5 kg. This is the third example. Okay, next example let us see in next part.